So imagine being forced to lock yourself away in your house for over a year because a deadly pandemic is ravaging your entire country. Sounds, well, a bit too familiar, doesn't it? But back in 1665, a young university student faced this exact scenario during the Great Plague of London. And instead of just, waiting it out, he actually used that intense isolation to completely rewrite the rules of the universe. Welcome to this explainer. Today, we're taking a fascinating three-act journey through the complex, sometimes shocking, and just brilliantly multifaceted life of Sir Isaac Newton.
It's a pretty profound question to start with, right? How did a deadly plague quarantine change the world forever? When the Great Plague hit in 1665, Newton was just a 23-year-old student who had recently earned his undergraduate degree. To escape the horrific disease wiping out London, he retreated about 60 miles northwest to his family farm at Woolsthorpe Manor. And in that totally quiet, serene environment, free from the constant interruptions of university life, his mind was allowed to just journey to the farthest reaches of imagination. This incredible period became known as his Year of Wonders, and it set the stage for everything that followed. Section 1. The Year of Wonders. This brings us to Act 1 of our story, The Isolated Genius, where a 23-year-old student retreats from Trinity College to the absolute serenity of Woolsthorpe Manor. Okay, let's dive into this. Shut out of Trinity in 1665, Newton turned his massive intellect to some equally massive, unsolved problems. First off, by the end of 1666, he invented fluxions, which is what we now call calculus. But he definitely didn't stop there. He literally drilled a hole in his window shutter, using prisms to prove that white light is actually a full spectrum of colors. And finally, watching an apple fall, he realized the force pulling it down was the exact same force pulling the moon. In less than 2 years, he laid the foundational groundwork for universal gravitation. Just mind-blowing.
Section 2. The First Reflecting Telescope. Fast forward to 1668, where Newton applied his new optics knowledge to solve a huge problem with refracting lenses behaving like prisms.
Take a look at this. This is a replica of Newton's very first reflecting telescope. Newton realized that the glass lenses in traditional telescopes were acting just like his prisms. They were distorting stars into a messy rainbow of colors, which is called chromatic aberration. His solution? Ditch the lens entirely. He custom-makes a special speculum metal alloy to create a tiny 1.3-inch concave mirror, and with just this tiny physical instrument, he could clearly see the moons of Jupiter.
And this brilliantly illustrates exactly how he pulled it off. Light enters the tube and hits the curved primary mirror at the back. But the absolute genius part is the flat, diagonal secondary mirror placed right near the focal point. It catches that reflected image and bounces it at a perfect 90-degree angle right out to a side-mounted eyepiece. This Newtonian design meant you could finally look at the stars without your own head literally blocking the incoming light.
But as with all great inventions, there were trade-offs, right? On the plus side, his design completely eliminated that annoying color distortion. It was far cheaper to produce because only one surface needed complex shaping, and it allowed for a super compact design. But on the downside, well, the mirrors tarnished really easily, making the image quite dim. The design also suffered from off-axis coma, making stars at the edges look a bit like tiny comets, and keeping those mirrors perfectly aligned was just a constant headache. Because it was so hard to perfect, it actually took another 50 years before a man named John Hadley improved the design enough for it to truly catch on and dominate astronomy.
Section 3. Writing the Principia. Welcome to Act 2, The Reluctant Giant, where Newton returns to intense, isolated work between May 1684 and April 1686, completely abandoning all his other projects.
His secretary, Humphrey Newton, observed that he sometimes forgot his food, or his sleep, or the state of his clothes. Talk about single-minded obsession. During this period, Newton entered a state of sheer, unadulterated focus. He dropped his regular chemistry and alchemy experiments entirely. His notebooks from this era are completely blank of anything else. He wouldn't sleep, he wouldn't eat properly, he would literally rush back from the garden just to write a thought down without even bothering to sit. He was a man entirely possessed by his work, breathing life into his eccentric personality as he compiled his monumental laws of motion and gravitation.
That obsessive work became the 1687 Principia, and within his later revisions of it, we find a phrase that basically defined modern science, hypothesis non fingo, which translates to I feign no hypotheses. This was Newton drawing a massive, unmistakable line in the sand. He was stating that in natural philosophy, if you can't derive a conclusion directly from experimental or observational evidence, it's just mere speculation. You don't just guess, you prove it. This strictly empirical methodology forever cemented the foundation of classical mechanics.
Section 4. Clashes and Controversies. Now, let's shift the narrative to the darker side of his public image, because Newton was a man known for his fierce, intense, and lifelong rivalries over intellectual priority. This sparked one of the absolute greatest feuds in scientific history, Newton versus the brilliant German mathematician Gottfried Wilhelm Leibniz. Now, this wasn't just a bitter race over who invented calculus, it was a profound philosophical disagreement. Newton invented his fluxions first, but kept them completely secret. Leibniz developed differential calculus independently and published his notes openly. Worse still, Leibniz publicly mocked Newton's idea of gravity, this invisible action at a distance, saying it sounded like medieval occult magic, because Leibniz strongly preferred a strictly mechanical view of the universe.
Newton's response? Absolutely ruthless. His official, unyielding stance was simply, second inventors have no right. He and his incredibly loyal supporters viciously accused Leibniz of plagiarism. They leveraged Newton's massive influence as president of the Royal Society to try and utterly destroy Leibniz's reputation, even suggesting Leibniz had stolen ideas from a book of geometrical lectures by Newton's predecessor, Isaac Barrow. It was a vicious, decades-long war.
Section 5. Master of the Mint. Enter Act 3, the surprising second act, where Newton abruptly leaves academia for a public office at the Tower of London in 1696.
Now, what's really interesting about this slide is that he didn't just sit behind a fancy desk. At the Royal Mint, he became a super hands-on administrator, overseeing the massive Great Recoinage. He even played detective. He was personally interrogating criminals and informers to hunt down counterfeiters. He was legendary for his administrative integrity, famously refusing a massive 6,000-pound bribe. He basically applied the exact same ruthless precision to the nation's money as he did to the stars.
Section 6. The Secret Mystic. Because while he was publicly serving as this strict mint administrator, we have to transition to his shocking private life, decoding biblical prophecies.
The ultimate man of reason was, it turns out, secretly a deeply devoted, almost obsessive theologian. In extensive, posthumously published writings on the Book of Daniel and the Apocalypse of St. John, Newton applied his genius-level analytical skills to decoding biblical prophecies. He truly believed that the hidden truths of the Bible were a massive puzzle meant to be solved, but one that would only make sense to a select few as the end of the world approached.
So the crucial point is, based on his meticulous private calculations of biblical texts, Newton projected a very specific year for the end of the world as we know it, 2060. But importantly, he didn't view this as some fiery annihilation. Actually, scratch that. It's more like his calculations pointed to 2060 as a transition point, the moment when the Earth would be replaced by an era of divinely inspired peace, the establishment of the kingdom of God on Earth. He was applying the mathematics of prophecy just as rigorously as the mathematics of gravity.
Which leaves us with this final, provocative question to ponder. Does knowing his apocalyptic secrets, his devastatingly bitter rivalries, and his surprising second act as a crime-fighting mint master change how we view the ultimate genius of reason? Isaac Newton wasn't just a man who sat under an apple tree. He was a fiercely complex, multidimensional character who completely reshaped our understanding of the universe, all while wrestling with the deepest mysteries of theology and human ego. Thank you for joining me on this explainer. Keep questioning, keep exploring, and I'll see you in the next one.